So we have another shear problem. If you missed it, we did a simple single shear shear problem. I'll put the card up here in case you missed it and you want to go back and do that first. This isn't a whole lot more complex, but this is double shear, so you might want to pick up the other one first. Anyway, what we have in this case, we have two plates, and the two plates are joined through two welds, one on either side of the narrower plate. And what we want to do is to figure out what the load is being carried by the weld, which would be a shear force, and then determine what load we could sustain if we limit the shear stress within those welds at 80 megapascals, based on what we know the capacity of the weld to be. So I've gone ahead and calculated the area of the weld. And so a weld has a geometric property called the throat, which is kind of that width, if you will, of the weld. Show it a little bit on the diagram. You can zoom in and have a look if you're interested. And you take the throat and you multiply it by the length and you get the area. So I've gone ahead and done that so it doesn't distract us from getting on with the problem about shear force. So I'm going to draw a shear free body diagram, and in this case, I'm just going to isolate on the smaller of the two plates. And we know that we have an external force acting on it of P. Now, to resist it, we have two welds. We have a weld on either side. And so each of those is going to have a shear force in it. And by symmetry, we know that they're going to be equal. So I'll just draw them in here. So we have a shear force down one side and a shear force down the other side, and each is equal to V. And so if we were to apply our statics, sum of the forces, we can make this X is equal to 0. And so we basically see that we have negative 2V plus P, and so V has to be equal to P over 2. So we know that the shear force in any one of the two welds is equal to P over 2. We know that what we want to do is we want to limit our average shear stress. So T average, or tau average, which we know is the shear force, or V divided by the area, is equal to our P over 2, which we already calculated for V. And we have an area of 1610 millimeters squared. And that needs to be equal to 80 megapascals at our high end. We don't want to exceed that. And so as long as we can calculate P such that this is equal to 80 megapascals, we just know that that's our upper bound or our upper limit for P. And so we can just isolate on P and come up with 257,600 newtons, or this would be equal to 257.6 kilonewtons. So that's basically double shear, and it doesn't really get much harder than that. We just, if we can get our free body diagram, if we can identify where our shear forces are, how many of them there are, really it doesn't matter if we had 2 welds, 3 welds, 4 welds, we would be able to derive this type of a problem. And so hopefully that was useful for you, and we'll be carrying right on and looking at some factors of safety coming up. Hopefully you join us.